In this video, we're going to take a look at subsequential limits, limit superiors, and limit inferior. So let's let S sub n be a bounded sequence. A subsequential limit of S sub n is any real number that is the limit of some subsequence of S sub n. So that is a subsequential limit. So if you have some subsequence of it, then whatever that sequence might have, whatever limit that sequence might have, that would be a subsequential limit. If you have the set of all subsequential limits, then we can define the limit superior, to be the supremum of the set S. So remember, the supremum is the least upper bound. So it's the of all of the upper bounds that you could have for that set, it is the upper bound that is the smallest. And if we have that set of all subsequential limits, then we can define the limit inferior. That is the infimum of the set S, right? And so it is the greatest lower bound. Out of all of the lower bounds, it is the lower bound that is the greatest, that's the largest, right? So that is our limit superior and the limit inferior, a subsequential limit. We will take a look at these in some specific examples in the next video. But let's look at some properties of these and some theorems related to these limit supremums, limit infimums. Right? So one property is the lim inf, the limit inferior. It should always be less than or equal to the limit superior. And then the other thing that we would have is if we have a sequence that converges to S, then the lim inf and lim sup, those two limits, the supremum and the infimum of the set of all subsequential limits, those should be the same. Because if you have a convergent sequence, then all subsequences should converge to the same value. So those values would have to be the same. If we have a bounded sequence, right, so if S sub n is a bounded sequence and M is the lim sup, then we have the following two properties must hold. Right, so for every choice of epsilon, there exists a natural number n, such that whenever little n is bigger than that natural number, the terms of the sequence after that point, after the big N term, all those following terms should be less than the limit superior plus that value of epsilon that you've defined above, defined previously in that portion. And for epsilon greater than 0, and for every I, natural number I, there exists a natural number k with the value, when the value of k is greater than the value of I, then our terms are going to be more than m minus epsilon. So S sub k is going to be close to m within epsilon units of m. Right. We can say a little bit more, though. This turns out that if m is a real number that satisfies a and b, so if you have a real number that satisfies those two things, then that real number has to be the limit supremum. As a corollary to this example, we can say that whenever we have a bounded sequence with this limit superior, then M is in S, where S is the set of all subsequential limits, right? So whenever we have this, M is a subsequential limit, right? And that is to say that there exists a subsequence of S sub n that converges to M. All right. Thanks for taking time to listen. We will look at specific examples to build some intuition for subsequential limits in the next video. We'll talk to you guys later. Thanks. Bye.